So,
Good morning, everyone, and welcome to the lecture. This is lecture number 4, and we are dealing with center of mass of continuous bodies. In the last class, we had seen what the center of mass of some geometrical bodies. Do we remember this? Center of mass of all those bodies: ring, semicircle, semicircular disc, hemisphere, hollow hemisphere, and all that. Do we remember it, everyone? Because
Sure.
this is important for us to go forward. If you don't remember this, you will not be able to solve any question on this. Remember this?
Sure.
Okay. Then we can move ahead and we can write the next heading. The next heading is center of mass of composite bodies. So write the next heading, center of mass of composite bodies. Center of mass of composite bodies. What do you mean by composite body, first of all? Hmm. What do you mean by composite body? Center of mass of composite body. What do you mean by a composite body? What do you mean by a composite body? Hmm? Any idea what do you mean by a composite body?
Is attached to each other.
Yes, you will have not one, but you may have more than one bodies attached to each other, or kept close to each other, and we will have to find out the center of mass of that combined figure. How will you find out the center of mass of that combined figure? So to find out the center of mass of such a combined figure, we just use this x position of the center of mass, will be equal to, again I use the same phenomena, mixi summation divided by summation of mi. So basically what I am going to do, you- basically what I am going to do is find out the x coordinate of those bodies, multiply them by their masses, and add them and divide them by their masses. Similarly, for y position of center of mass, I am going to repeat the same steps. I am going to repeat the same steps. And this is how I can find out the center of mass of any composite body or any composite structure. Let us see how we are going to do it. Let us see with the help of a question. So I have this system. These are two rods. each of mass m and length L. This is the x-axis, this is the y-axis. Both the rods have mass m. Both of the rods have mass m and length L. This one as well as this one. The origin lies here. You have to find out the center of mass of this L-shaped figure. Center of mass of this L-shaped figure. I'll give you 2 minutes to give me the answer. I hope you understand how you will do with this. How will you do this? Yes or no? You know how to do this? Yes or no? You know how to do this? Do you know how to do this or shall I do it? Okay, I'll do it. No one is saying anything, then what do I do? So how are you going to do this? Are you going to try or shall I do it?
We will try, sir.
Okay, then try. If you're not able to do it, then I'll do it. How will you do it? Which formula are you going to apply? Okay, try. So how are we going to do this? I will call this. I will call this rod as rod number 1, and I will call this rod as rod number 2. And I will just apply the formula. We just had to apply the formula. I don't know what are you thinking. MIXI divided by summation of MI. X position of center of mass. M1 into X1. Where is the X coordinate of the first rod? Where is the position of center of mass of the first rod? The X coordinate. It lies at the center. No one remembers it. M into L by 2. Where is the coordinate of center of mass of the second rod? It lies on this line. It lies at 0. So 0 divided by M plus M. That was the answer. How hard it was to do it. I don't know what everyone is doing. Everyone seems to be writing something. I don't know what they are writing. If you don't know how to do it, tell me so that I don't waste time. Time is one luxury that I don't have. If we have no idea about things, just tell me, sir, we don't know. So there is no point of me wasting 5 minutes of the time of the class in giving you an attempt when you have no idea how to do it. Tell me that. What? Or if you ask for time, then tell me what you are doing. If you ask for time and then you are not able to tell me what you are doing and you don't do anything, it's a waste of time. You might have enough time in your lives, I don't. So if you don't know, just tell me that we don't know. So that I can at least solve this one and hope that the next one you will be able to do. Anyways. Next one is y position of center of mass. M1 into y1, the y position of the first rod, which is the blue rod, the y position of the center of mass will be 0 because it lies on the x-axis. So this is 0. Plus for the second rod, which is the green rod, the y position of center of mass, it will lie at the center of the rod. Mass is m. M into L by 2 divided by total mass of the system, m plus m. So the final answer that we are going to get is L by 4. So that is what you get. The x position of center of mass is L by 4. the y position of center of mass is also L by 4. That was the answer that we were looking at. So I'll give you 2 minutes to note it down. So now we move on to this problem. Problem number 2. We have this composite body. Number 1 is a disc. And number 2 is a square plate. This disc has a radius r, and the square plate has a length of the side also r. You have to locate the center of mass of this system. We can assume that mass of this disc is m, and mass of this square plate is also given as m. Both are having same masses. You have to find out the center of mass of this composite system. I'll give you 2 minutes to do it. So how are we supposed to do this? Which coordinate of the center of mass do we need to find? Do we need to find the x coordinate? Do we need to find the y coordinate? Or do we need to find both? Or we don't need to find anything? What? Which coordinate we need to find? Both? 1, 2, or nothing, or we don't know?
Both, sir.
Okay, both, sir. Good. How will you find out the x coordinate of center of mass? How will you find out the x coordinate of center of mass? Anyone knows the formula?
Summation of mi(xi) by summation of mi.
Okay. If I call this as body number 1 and if I call this as body number 2, tell me what will be the answer coming? Yes. Tell me. Whom should I multiply what with? Origin is here. What is the formula? No one knows it?
M into 4r by 3 pi, sir.
M into 4r by 3 pi. Which universe you are living? This is a disk. Where is the center of the disk? Which universe you are there? Center of the disk is at the center, bhai. This is the center of mass here. I hope we are in the same universe. We are in the same universe where the disk center is at the center of mass is at the center. We understand this? Do we understand this or not? From where 4r by 3 pi came? That means you have not even read what we have done here. Come on. Anyways. Okay, so just for the record, the center of mass of this full disk lies at the center. Okay, now can you now tell me what will be the formula if I have told you this? Just better. Boys, at least girls are trying, boys are sitting. Any idea how are we going to do this? I have marked the center of masses. Can you now tell me what will be the formula? No one knows it. So I have to multiply the first mass by the coordinate x coordinate of its center of mass. The center of mass of a disk, full disk, lies at the center. The center of this disk is at a distance r from the origin. The x coordinate is r, so it will become m from color m into r. I hope we understand this. We have to find out this distance. If you can see, we have to find out this distance, and you must know that the radius of the disk is r, so this distance has to be r. So far so good. Plus I have to multiply the mass of the second figure by the center of mass coordinate. Can you tell me what is the distance of that point from origin? What is the x coordinate? Or it is too hard for you to tell me?
M pi r by 2.
Huh?
M pi r by 2.
M pi. How come pi came here? Anyways.
Pi r by 2, sir.
Huh?
0. MR by 2.
I don't know which universe you are living in. Open your eyes. You have to find out this distance and how r by 2 is coming here. How pi is coming here. You have to find out this distance. I hope you understand which distance I am talking about. You have to tell
M
me.
phi r by 2.
Tell me this
0.
0. कुछ भी बोलते जाओ मुंह में जो है. So this distance is 2r plus r by 2.
M phi r by 2.
M into 5r by 2. The distance of that point from the origin O is 5r by 2. We understand this? Do we understand this? Or okay, on that note, divided by m plus m. This distance is 5r by 2. This is the x position of center of mass. Whatever you get from here, what are you getting from here? M and m will get cancelled. What are you getting? 7r by 4, I think. That is the x position of the center of mass. Do we understand this? Do we understand this?
Yes, sir.
What do we understand, sir? Okay. What is the y position of the center of mass? If you understand, then tell me. What is the y position of center of mass?
0, sir.
0, sir. So you don't have to find out because it is symmetrical. The y position is 0, sir. So you had to only find out the x position, and the x position of center of mass is 3r by 2. Do we understand this, sir, or bye-bye, sir? Please try and understand things. Things are simple if you try to make sense. If you do not make sense, is it so difficult to do this question? Huh? It's a simple question. Let me give you this in a different way. In the first case, I had given you the mass of the two bodies. Now, I'm not giving you the mass of the two bodies. I'm just giving you that this is R and this is R, and these two bodies are made from the same material. These two bodies are made from the same material. These two bodies are made from the same material. These two bodies are made from the same material. These two bodies are made from the same material. Now, how do you find out the center of mass? Now, since you have no idea, and I will not give you any more time to do it because it will just be a waste of time. Let's not waste any more time. These two bodies are made up of the same material. In that case, how do I find out the center of mass? So I assume something known as sigma. This sigma is mass per unit length. No, mass per unit area. Now remember, every body, now this body has got an area. So I have taken mass per unit area. If this body had a volume, I would have taken it as mass per unit volume. These two bodies are the same bodies. This is a disk and this is a square. Disk and square both have areas. So I have taken sigma. Sigma is mass per unit area. So if these two bodies are made from the same material, this sigma will be same for both the bodies. Mass per unit area would be same. These two bodies have area. Mass per unit area would be same. I have called that one as sigma. Now if I call this body as body number 1 and if I call this body as body number 2, I can find out the mass of body number 1. The mass of body number 1, M1, will be equal to sigma multiplied by pi r square. Pi r square is the mass of the disk. Pi r square is the area of the disk. I have multiplied it by sigma. So the mass of the disk becomes M1 into M1 becomes equal to sigma into pi r square. Do we understand this? On similar lines, I can find out the value of M2. M2 is the mass of the square plate, sigma multiplied by r square, because the area of the square plate is length into breadth or length square r square. Now, since masses were not given, it was given that it is made up of the same material. I have taken it as sigma and multiplied sigma with the area and found out the values of masses M1 and M2. Having found out this much, can you now tell me what is the position of the x? What is the x coordinate of the center of mass ka position? Can you find it out? And what is the y coordinate of center of mass? You can tell me y coordinate. How much will be the y coordinate of the center of mass? It's 0. It will lie on the x-axis only. Now, since we have already done the first question and I have told you how to go about this one, can you tell me what is the x position of center of mass? I will give you 2 minutes to do it. So, how are we supposed to get this? How do I get 7r by 4? It's not possible in this universe. Come back in this one. This is a good universe to live in. Don't wander here in this. Okay. So, to get the x position of center of mass, I have to do summation of mi xi divided by the summation of mi. So x position of center of mass, the first mass is m1 and m1 is sigma into pi r square. What is the distance of center of mass of this one from the center?
R, sir.
R, sir. Good, sir. Plus sigma into r square. What is the distance of center of this one from the center of the
5R
from
by
the
2.
huh?
5R by 2.
5r by 2 divided by sigma into pi r square plus sigma into r square. That is the answer that you are going to get. Beta r square, r square, r square, r square will get cancelled. Sigma, 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 sigma will get cancelled. And whatever remains will be the answer. And I think the answer that you gave, bacha, was correct. 2 pi plus 5 times r divided by 2 times pi plus 1. This is the answer that you will get. And this is the answer of the thing. Do we understand this? Yes or no? This has gone above our head saying bye bye, bye bye, bye bye, bye bye, bye bye. Everyone understood how this is to be done? Yes or no? Everyone has noted this down? Everyone has understood this, noted this down?
Done, sir.
So this is the next question that I have created. This is a composite figure made up of the same material. You can call this one as the height is given as 2 times r, and the radius, this is a semicircle disk, radius is r. Remember, this is a triangular sheet. The blue one is a triangular sheet. This is a triangular sheet of height and width, whatever is required is given. I think this is a, and then you have a half disk, a half disk. Oh, don't take it as disk, take it as, oops. Don't take it as disk because disk it will become a problem to calculate. Take this as the upper body as a solid cone. And take the lower body as solid hemisphere. Now, solid cone, solid hemisphere. Which coordinate you need to find out in this diagram. Now, if you choose your coordinate system correctly, which coordinate you need to find out in this diagram? Tell me. Which coordinate of center of mass do you need to find out? X or Y or Z? Which one?
Y coordinate, sir.
Because we have chosen the x-axis in such a way that the x coordinate of the center of mass would be 0, yes or no? The z coordinate of the center of mass will also be 0. The only thing is this figure is not symmetrical about the x-axis. We need to find out the y coordinate of center of mass. Do we understand this? Yes or no? Again, it is given that this is made up of body of the same material. Solid cone, body of the same material. Body of the same material. Can you locate the center of mass of this composite figure? I'll give you 2 minutes to do it. For this, you will have to just remember what all things we had studied in the previous class.
Sir, mass is same, sir. Sir, what about the mass?
What was the mass? Was the mass given in the last question?
Sir.
In the last question, was the mass given? Did you hear the entire question that I said?
Yes, sir.
What did I say in this question?
We have to find the mass.
How will you find the mass? It is made up of the same material. Listen to the question carefully. You don't listen to it. So how are we going to do this? Let me call this body as body number 1. And let me call this body as body number 2. First of all, I have to find out the mass of this body. How will I find the mass of this body? M1, any idea? How will I find the mass of this body M1? Any idea?
Sigma into areas.
Rho, which is mass per unit volume. Cone has a volume. So solid cone. Cone has a volume. Rho multiplied by the volume of the cone. What is the volume of a cone? You must not be knowing it. 1 by 3 pi into r square into h. The height of this cone is 2r. So that is the area of this, that is the volume of this cone. And I will get pi rho r cube by 3. That is the mass of the solid cone. To find out the mass of the entire cone, area will not do anything. If it was a hollow cone, then you would have to use the area anyways. Then I have hemisphere. What is rho here? What is rho here? Mass per unit what?
Volume.
Density. This is mass per unit volume. This is density. So M2 will be equal to rho into the 2 by 3 pi r cube. The volume of a hemisphere. So it is 2 by 3 pi rho r cube. Now you can proceed and find out the center of mass. Where does the center of mass of this one lie? You know it from your previous thing. Where does the center of mass lie from the bottom for the solid cone? Anyone remembers? Here is the origin. Where does the center of mass of this solid cone lies? No one remembers? So it's of no use. H by 4, total height by 4. So it is 2r, the total height divided by 4. Where does the center of mass of this one lie? Hemisphere. Anyone remembers? No one remembers. So there is no point of going. 3r by 8. So now I can find out the y position of center of mass, summation of mi, yi divided by summation of mi. So the y position of center of mass, m1 is rho pi r cube by 3 multiplied by 2r by 4, that is on the positive side, but green mass is on the negative side, so y coordinate is negative, so I write it minus 2 by 3 pi rho r cube multiplied by 3r by 8. The problem will look a bit complicated because of numbers. Then the total mass pi rho r cube by 3 plus 2 by 3 pi rho r cube. Solving this, you will get your answer that I will leave for you as an homework so that you can go back home, see how it is done. Why this minus sign has come here?
Negative x-axis, y-axis.
Negative y-axis. This one has the because I have taken the origin above it. The center of mass of this one has lied below, and that is why we have a negative sign. I will leave this calculation for you to do at home. This is how. Now this question has not come, so it is a tough question because it requires a lot of calculations, so you may not get this, but yeah, you can definitely get question of two rods, disc and a circle, disc and a square. You can get, you may not get this because just requires calculation. Anyways, I have told you how to do this. Everyone has understood this? Well, on that note, we will wind off the class. Anyone has any doubts in this? What I will suggest is go back home, see how we have done this. If it was area, we have multiplied sigma by area. If it was volume, mass was in the volume, we divided rho by volume and just use a simple formula. We will continue with this in the next class. We will see some more figures. Anyone understood this? Can you raise your hands and let me know that we understand this? Boys and girls.
Sure.
Anyone understood this? Pakka? Okay, then we'll see you in the next class. Take care. Have a nice day. Bye bye.
Thank you, sir.